talk about this new idea called overloading. Overloading refers to when we define multiple functions that each have the same name but accept different parameters. So as an example, we can create functions with the same name like this print function here. These functions will each print out whatever parameter that we pass in. It could be an int or a double or a string, and it shouldn't matter. We want to accomplish the same thing across all of these functions, which is to print out the input to the console. So if I were to call this print function in my code, the compiler would need to decide which of these three functions to call. So say I make a function call and I type print hello world. The compiler would look at the type of the argument that I'm passing in and then the number of arguments that I'm passing in as well. And that's what it uses to decide which of the functions that it needs to invoke. So it's going to be based on the types and the number of arguments that the caller passes in. So if I write print hello world, the compiler is going to see you're trying to call a function called print and you're passing in one string argument. It's going to look through these function declarations here and it's going to try to match as best as it can. So is there a print function that accepts one string argument? And there is. So it knows that that print function is what it's going to invoke. So overloading applies also to constructors because constructors are functions. And we've actually already done this before and we're just now giving it a name explicitly. So this is something that you've already seen. So if we want to create multiple constructors that each accept different parameters, this is called constructor overloading. And just like before, the compiler is going to decide which constructor to invoke based on the number and the data types of the arguments that you pass in when you call the constructor. So we have 3 volunteer constructors here, one default constructor that doesn't take in any parameter, one constructor that accepts the age, and then we also have a copy constructor. So why do we need overloading? Overloading makes our lives a little bit easier because we don't need to name our functions different things if they perform the same action, right? So if we didn't have overloading, we'd have to do something like this. We would have to write a different name for the same, effectively the same function that accepts different parameters. So for a function that prints ints, I'd have to call it print int. And then a function that accepts doubles, I call it print double and print string. So this would be pretty tedious. If we didn't have overloading, we know each of these functions accomplish the same thing, but they just accept a different type of parameter. If I had to think of a different name for each of these functions every time, that could be very, very cumbersome. So overloading makes our lives a little bit easier, and it also improves readability because we know that each of these functions are effectively the same thing. They all accomplish the same task. So we can call them all print, and it makes it way more clear in our code what we're doing. So for these lines of code, I want you to take a moment to try and guess if you think that this is a valid use of overloading. So try and predict. You can feel free to pause if you need a little bit more time, but try to guess if this would compile. So in this case, the answer is no. The compiler would get mad if you try to do this. Remember that when we're overloading functions, the compiler decides which function to invoke based on the number of arguments that we pass in and the types of those arguments. So in the last 2 enroll student functions that we have here, we are accepting one string argument. So both of them accept one string argument. What that means is that if I called enroll student and I passed in a string like JC, it would see that there are 2 enroll student functions that each accept one string argument, and the compiler wouldn't know which one to call. It doesn't determine which of these functions to call based on the return value, because when we call the function, we're not saying, give me the function that gives this return value back to me. So if I just pass in one singular string argument to enroll student, the compiler would look at this and it would not be able to resolve any ambiguity. It doesn't use the return value to resolve that ambiguity. It's just the name or the type and the number of the argument that we're passing in. So how about this one? We have 2 function declarations here for enroll student. They each take a string parameter, but they're named something different. So would the compiler be able to tell the ambiguity now and resolve which overload should be invoked? Take a moment to pause if you need a little bit more time to guess. So the answer for this is no. It also would get mad at you if you tried doing this. And the reason is we don't resolve the ambiguity on which overload should be called based on the name of the parameter. If I called enroll student with a string, it doesn't matter that the parameter is called name1 or name2. The compiler would look at the string that I'm passing into enroll student, and it would see these two function declarations and not know which of these to invoke. So this would be a compiler error as well. How about this? We have 3 enroll student overloads here. Would this compile? Take a moment to pause if you need. So this is actually perfectly fine. Each of these overloads has a different type or different number of parameters, so it is the compiler is able to resolve any ambiguity. I can either call enroll student with an int, I can call enroll student with a string, or I could call enroll student with 2 strings. The compiler would say that this is totally fine because it bases which function overload to invoke based on the number of parameters and the number and the type of each of those parameters. So in this case, since each of these function declarations has a different type or a different number of parameters, this is a totally perfect use of overloading.